Trig folks, I just wanted to go over a couple of things before Chapter 1 exam. Some things I noticed on the quiz, some common mistakes, and things I want to clarify. Okay, so I'll make a quick video. This is from 1.4. I thought that we could go over it. The first thing is, if they're given sine of theta is equal to -2/3, I want you guys to start picturing where that might live in the xy plane, the Cartesian coordinate plane. So we'll talk about that in a second. Remember the ratio for theta is, and this is theta, this is any angle. This is not just an acute angle, okay? So we're leaving the right triangle world when it talks about theta, and we're going to anywhere in the xy plane. So we have the ratio of sine is y over r. That tells me that I know that I have y is equal to -2. R is always positive because that's the distance from the origin, so R is equal to 3. So if we think about where that lives, well, -2, I'm going to go down 2 units here, right? And the distance is going to be 3, so it's going to live somewhere, like if I were to draw this, somewhere down in this region. So it's kind of hard to draw your triangle just yet, but we've got that this leg right here, because this is y, is 2. And notice I'm going down 2 units, okay? But the length is 2. We can just say it's -2. And this radius right here, or the distance from the origin, is 3 units. So this is my right triangle, and this is how I find x, okay? So then I say x squared plus 2 squared is equal to 3 squared. X squared equals, that's 9 minus 4, which is 5. So x is equal to the square root of 5. Now, in this case, because of the -2, you can also be, and let me change the colors, since y is negative, y could also be going down in this direction, -2. This would also make x a negative square root of 5, but the distance is still 3, okay? So those are my two cases. I'll keep those in red. So let's just do red since we're doing that. So that means that the cosine of theta is equal to, and I know that that is x over r, right? So in red, x is negative square root of 5. R is still the same, positive 3, okay? Tangent of theta is equal to y over x, and in this case it's square root, or -2 over the square root of 5, negative square root of 5. Okay, so that ends up being positive, so tangent of theta is equal to 2 over the square root of 5. All right, now going back to the original triangle in the green realm, cosine of theta, if I'm looking at these two sides, I know that x is equal to this positive square root of 5. So cosine of theta is square root 5 over r, which is 3. Tangent of theta, once again, it's going to be, let's see, it's going to be y, which is -2 over the square root of 5. So it actually, tangent of theta, you have two different values. This one's negative and this one's positive. Let's look at the tangent theta equaling 1. Well, what does that mean? Okay, well that tells me that tangent of theta equals 1. I know from ratios the tangent of theta is y over x, right? So in that case, if it's equal to 1, that means that y is equal to x. Does that make sense? And it also has to be positive. So you guys had to explain this on the quiz. In what quadrants is tangent positive? It's positive up here, and it's positive in quadrant 3, right? Because the signs are the same. So, and when are points equal? Well, if you think about it, anywhere along this xy plane, remember this line y equals x? These points are equal. So we could say that this point, 1 would work, and this point, 1, -1 would also work, okay? To find out what this length is, we could use the Pythagorean theorem. So we have 1 squared plus 1 squared equals r. That's the distance from 0, right? So that's 1 plus 1, that's 2. So that tells me that r is equal to the square root of 2. It's always positive, okay? So my two cases, For positive, we have sine theta is positive 1 over, because that's the y, over r, which is square root of 2. Cosine theta is also positive 1 over the square root of 2. If you rationalize the denominator, that would be root 2 over 2. And this is also root 2 over 2, which you might see. Okay? Same now if we did sine theta in quadrant 3. So for quadrant 3, sine theta would be negative 1 over the square root of 2. And cosine theta would also be negative 1 over the square root of 2. Another little quick note on when you're doing your radicals and your ratios, your trig ratios, I want you to simplify. So if you had something like 2 square root 24 over 6, for instance, to simplify that, in this radical, it's 4 times 6, right? So it would be 2. I can bring out that square root of 2, which is 2 root 6 over 6. I'm going to cancel that out. That's a 3. So now I have 2 rad 6 over 3. Okay, so just be sure to simplify, and I'll write that on the exam to remind you guys. That was for questions 1 and 6. Some of you didn't simplify those. The other note that I wanted to mention was number 4. I thought that I could set up number 4 in the quiz for those of you who didn't understand that. If you get it, that's great. So the angle of elevation, to figure out an angle of elevation, it says it's from the ground. So it's 64 degrees from the ground up to this hot air balloon, and this distance is 2,800. Some of you guys were getting fancy and starting to use different ratios, but in this case we just need to find x, and we don't need to use the Pythagorean theorem, so keep it simple. The tangent of 64 is equal to opposite 2,800 over x. That means if you solve this, that x is equal to 2,800 over tangent of 64. This approximately, I'm going to keep it exact, but you could approximate this. It's 1,365. I'm going to leave it like that. So now, at a later time, we have the balloon lowers, and it's down to 1,400 feet. And so here's this distance right here. We need to find angle theta, the angle of elevation. So do you see now that we can use this side and this side? So I don't need to find the hypotenuse here. I just need to use what I have, okay? So use that tangent of theta now is equal to 1,400 over x, and in this case I know that x is 2,800, so I'm going to plug that in. And just my preference, I'm not going to be too picky about this, but I prefer to keep things in exact form until the very end, because that's the most accurate. And if you're getting into engineering or anything like that, you should do the same. So tangent of theta, that means that the bottom gets flipped, so it's 1,400 tan 64 over 2,800, and then you do the inverse. It's tan inverse. That means that this stuff goes here, the 1,400 tan 64 over 2,800, and this gives you theta. Now, the only time that you use an inverse is when you're trying to find the angle. So use inverse when the angle is unknown. That's the only time that you're going to use the inverse. Okay, I think that covers everything from the quiz. I had some help with grading the 2 assignments from last week as well. We don't grade them all, we grade some of them because we would be there forever. I think I've checked in with all of you about where you're going to take the exam. If you're taking it before 3, you're going to take it in the math lab. If you're taking it after 3, I'll bring a copy for you down in the library. So if you have any questions, let me know, and good luck, and please come see me. I have office hours tomorrow, Wednesday, from 10 to 11. So good luck, everybody. Keep up the good work.